Alright guys, we are going to go over the homework 5 really quick before we start the lesson. So you can check your homework. This says, what is the domain and range? So we went over how to properly write in interval notation. So remember, the domain only talks about the x values. So you go to the x-axis. We have the lowest value on the x-axis was 0. T for time, and then we have the highest x value for time is 9. Okay, so same thing for range. Range only talks about the y values, so I go to my y-axis. The lowest y value is -4, so that's -4 less than or equal to d for distance. Less than or equal to my highest distance is 2. So that would be the domain and range. What is the total distance Billy traveled? So Billy traveled 4 foot right here. He didn't travel anything here because this is a horizontal line. From here to here, he traveled from -4 to 2, so that would be 6 feet. Didn't travel any here, and then from here to here, he went from 2 to 0 feet, so that's 2. So 4 plus 6 plus 2 gets me a total of 12 feet. So you would just write the total distance Billy traveled was 12 feet. Okay. How many seconds was Billy actually walking? He was walking here, which took him 1 second. He was walking here, which took him 2 seconds. And he was walking here, which took him 1 second. So 1 plus 2 plus 1 is a total of 4 seconds. So you would say Billy walked, or actually walked, for 4 seconds. What is Billy doing on the time interval from 1 to 5? So the easiest way is to go from 1 to 5. And what is Billy doing from here to here? He's doing nothing. He's resting. So Billy is standing still from the time interval 1 to 5, or he's resting, or he is stopping, something like that. Okay. 3 questions on number 5. How far does Billy walk from the time interval 5 to 7? So from 5 to 7, Billy walked a total of 6 feet. Okay, so from the time interval 5 to 7, Billy walked 6 feet. Second question is, how long did it take him to walk this distance? So from 5 to 7 is 2 seconds. So it took him 2 seconds to walk 6 feet. So you would say it took Billy 2 seconds to walk 6 feet. And then the last question, what is his rate he is walking in feet per second? So he walked 6 feet in 2 seconds. So that means 6 divided by 2 is 3. So he walked 3 feet per second. Okay. Number 6, how many times is Billy 1 foot from his starting point? So we take a horizontal line. We go 1 foot. Whoops. And then he's also 1 foot away here. So Billy is 1 foot from his starting point 1, 2, 3, 4 times. Okay, during which interval is Billy traveling the fastest? So on the previous question, we already determined that from here to here, he was traveling 3 feet per second. From here to here, he goes 1 second, but he goes 4 feet, so that would be 4 feet per second. And then from here to here, he's going 2 feet in 1 second. So where is he traveling the fastest? He is traveling the fastest from 0 less than or equal to t less than or equal to 1. Okay, next question. Write in a few sentences describing what happens on the graph. So all this is writing bullet points like we had on Unit 1, Lesson 1, Walk the Line. So you would just say something like, Billy started at 0 seconds, at 0 feet. He walked to the left 4 feet in 1 second. I know he walked to the left because the line is decreasing. He rested for 4 seconds. Billy then walked to the right 6 feet in 2 seconds. Then Billy rested for 1 second, and then Billy walked to the left 2 feet in 1 second. Okay, so now we're actually going to look at Lesson 2. It is called average rate of change, aka slope. So notice when it asks you find the average rate of change or find the average speed, it is asking you to find the slope. Okay, so the formula for slope is this. So I would pause the video and make sure you write this down in your notes. The average rate of change equals change in y over change in x. Usually, probably the way that you've seen this written is not written out this way. You've probably seen it like this. M equals y2 minus y1 over x2 minus x1. This is called the slope formula. It means the same thing. Both of these are the same thing. Also, something that means the exact same thing is delta y over delta x. Those are Greek symbols. Delta is just like a little triangle, but again, it means the exact same thing. Okay, so definitely pause the video and write those down real quick. Okay, so the first question is, Al is an avid cyclist. On a recent ride in the country, he traveled at a constant speed throughout the trip, and then use the graph to answer the questions. So the very first question is, how far did Al travel in 3 hours? So from 0 to 3 hours, at 3 hours, Al was at 54 feet. So your sentence would say, Al traveled 54 miles in 3 hours. Okay. The next question, does the graph represent the path on which Al is traveling? The answer is no. Remember when we did the path in lesson 1, it was a number line where we went from right to left to right to left. This does not show the path. So you would say no, the graph represents Al's time and miles traveled. It does not represent the path. Letter C, what is Al's average speed in miles per hour for the time interval 0 to 3? Okay, so this is the first one where we're going to use that formula that we had on the previous page. So what you do is you find your coordinates. So the question asks, what is the speed from 0 to 3? So I go to 0. So at 0 hours, Al's speed is 0. So that would be 0, 0. Okay, and then it says from 0 to 3. So at 3, Al's distance is 54. So that would be 3, 54. Okay, so I label these as x1, y1, x2, y2, and then I fill into my formula. So remember, my formula was y2 minus y1 over x2 minus x1. So y2 was 54 minus y1 is 0. x2 is 3 minus x1 is 0. So 54 minus 0 is 54. 3 minus 0 is 3. And then 54 divided by 3 is 18 miles per hour. Okay? Alright, so you would write a sentence saying Al's average speed for the time interval 0 less than or equal to t less than or equal to 3 is 18 miles per hour. Okay, so the next one, letter D, says what is Al's average speed in miles per hour for the time interval 1 to 2? So now I'm going to 1. So at 1, Al's speed was 18. So that's 1, 18. Okay, and then at 2 hours, Al's distance was 36. So that is 2, 36. And you do the same thing again. This is x1, y1, x2, y2, and then you plug it into the formula. So 36 minus 18 over 2 minus 1 equals 18 over 1, which equals 18, and then you put the miles per hour as well. So I'm going to write 18 miles per hour. Okay, so sentence, Al's average speed for the time interval 1 less than or equal to t less than or equal to 2 is 18 miles an hour. Alright, and then last question, is Al's average speed increasing, decreasing, or remaining constant? So a lot of people want to pick that it's increasing only because they're looking at this line and it looks like it's increasing, but this is not what it's asking about. It's asking about his speed. So his speed were these numbers that we calculated over here on the side. And notice they were the same number. So since they were the same number, that means his speed was remaining constant. So Al's average speed is remaining constant. Okay, next question. It's still about Al, but this time there was road construction. So due to the construction, his speed varied. So I'm just going to do a couple of these because they're pretty repetitive, so I'll let you finish the rest on your own. So we'll do A. Okay, so A says, what is Al's average speed from 0 to 5? So at 0 hours, his distance is 0, so that's 0, 0. And then at 5, his distance is 60, so that would be 5, 60, and then just plug it into your formula. 60 minus 0 over 5 minus 0 equals 60 over 5, which is 12 miles per hour. And so you just say, your sentence would say, Al's average speed for the time interval 0 less than or equal to t less than or equal to 5 is 12 miles per hour. Okay, and let's just skip down. We'll do D. So D says, what is Al's average speed from 2 to 4? So at 2, his distance is 33, so that would be 2, 33. And then at 4, his distance is 42, so that would be 4, 42. And then in your formula, so 42 minus 33 over 4 minus 2. So 42 minus 33 is 9. 4 minus 2 is 2. And then 9 divided by 2 would be 4.5 miles per hour. So your sentence would say, Al's average speed for the time interval 2 less than or equal to t less than or equal to 4 is 4.5 miles per hour. Okay. F and G, you're just looking at the graph. F says which one is he cycling the fastest, so you figure out which one has the fastest rate. And then G, which one is the slowest, so you go to each one of these and figure out which one was the slowest. Okay. All right, last question, question 3. It gives you a table this time instead of a graph, but you're doing the exact same thing over and over and over again. So I'll do a couple of these with you, and then I'll let you finish. So the very first one is City A. So notice this top one is City A. Okay, we're going to do it from 1990 to 2000. So from 1990 to 2000. Okay, so at 1990, my population was 42,000, and in the year 2000, my population was 72,000. Okay, so let's work that out. So my first coordinate would be 1990, 42,000. And then my second coordinate would be the year 2000, 72,000. All right, and then plug it into your formula. 72,000 minus 42,000 over 2,000 minus 1990. So 72,000 minus 42,000 is 30,000. 2,000 minus 1990 is 10. And then 30,000 divided by 10 would be 3,000. And then my units of measure would be people per year, because population is made up of people. Okay, so that was all for City A. All right, so an example, we'll do City B, 1995 to 1998. So City B from 1995 to 1998, and those were 70,000 and 65,000. So my coordinate points would be 1995, 70,000, and 1998, 65,000. Okay, and then formula, 65,000 minus 70,000 over 1998 minus 1995. So that gets me negative 5,000 over 3, which is negative 1,666.7 people per year. So what this represents is it was declining. The population was decreasing.